Hello, everyone. I'm Martin Willis, your host, and I'm really excited about this evening's show. Countless times over human existence, advancements in science have been curtailed basically because of fears and egos. And the one, I often think of when it comes to this in advancement, when it comes to astronomy and things like that, is when Galileo basically understood that Copernicus's, that's kind of a hard name to say, his idea of the heliocentric theory that the Earth is not the center of the universe. Look what happened to him. The Roman Catholic Inquisition of 1633, I think it was, basically sentenced him to house arrest for the rest of his life. He lasted 10 more years in house arrest. And all along, he was right to think out of the box. And even now, there are a lot of scientists that kind of have the same attitude that, they should know something. So if they don't know it, then it can't be so. And it's kind of like, the universe evolves around us. And I like when people can have an open mind and they dare to look outside of the box of most thinking and take a chance. And this is what our guest did tonight. He is Avi Loeb. He was the longest serving chair of Harvard's Department of Astronomy and so much more. He was involved in the Breakthrough Initiative, the Starshot, which I think was really interesting. I think that might have had some influence on his thoughts about the Oumuamua, the strange object that first came through our solar system back, I think it was 2017. I read the book. I really loved his book, and it's called Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. I was thinking today, I wish I was an astronomer so I could ask really good questions. And all of a sudden I thought, I know an astronomer. Why don't I ask him for some questions? And then he sort of invited himself on the show. So he'll be joining us, Marc D'Antonia, in the second hour of the show. And I'm sure he'll have some great questions. And I know I got a little inside that he's kind of on the same track with Avi on what this thing is. And so that should be interesting. In the very last half hour of the show, we'll be taking calls. Bill will be we're screening the calls. And so think up some great questions if you'd like to call in. And that's the last half hour. We will be taking a break at the top of the hour. At that time, I'm going to bring in Marc D'Antonia. We're going to talk a little bit and then come back again with Avi. And I've been getting pics from listeners all over the world. Thank you so much. And if you want to send me one and a picture of yourself or something that represents the location, I created a new email address for that. It's called GPS@Podcast UFO. And there's also a page on the website, podcastufo.com, that you can look at all the listeners' pictures from all over the world. One from Iraq, actually, and everywhere. And there's another great blog this week by Charles Lear, who creates an audio blogs for every Friday afternoon, or mostly every Friday afternoon. This one's called More Metal from the UFO, the Bob White Object. And I've seen this metal. It's a strange cone-shaped piece, but I'm not going to say it's extraterrestrial. Who knows what that is? But we'll be talking more about extraterrestrial objects in just a minute with our guest. If you support the show, I want to thank you so much. And check out our Facebook page. And I hope you're in chat tonight if you're watching live on YouTube. And if you want to post questions, just make sure you put them in all caps so I can see them and pay attention to them. But I will only post those questions when they make sense at the time. I may have to go back to them later. But for right now, I'm bringing in our guest. Welcome to the show, Avi.
Thanks for having me.
Thank you. And as you probably just heard, I loved your book. I really enjoyed it. And I like, I'm not an astronomer. I'm not someone in science, but I like that I could read that book and understand it. You used a lot of analogies that were really helpful. Mm-hmm. And
well, I only explain things that I understand. That's what I tell my students.
Yeah. And I like, you brought a lot of the child thinking in it, like what your daughters thought about certain things. I love the story about the tidal, I don't know what you call it, when something's gravitationally in a tidal lock or whatever it is around a sun, and your daughter said she wanted to get a house in the dark side so she could sleep in a house in the light side.
Oh, yeah, that's actually the nearest star is Proxima Centauri. It's 4 light years away, and it's a dwarf star. And next to it, there is a planet which is 20 times closer to that star than the Earth is from the sun. And because it's so close, it's tidally locked, just like the moon is to the Earth. And it shows the same side at all times. So there is a permanent day side and a permanent night side. And actually, it's just at the right distance to have room temperature on the day side. So my daughter said if we ever go there, we should have, she would like to have 2 houses, one in the permanent night side where she can sleep, and the other one in the permanent sunset strip between the night and day sides, so that she can have her vacation with the sunset forever.
That's great. Well, if she was really thinking, she'd build a large house right on the border, so she'd go into the back and sleep at night. but anyway, in a situation like that, and I'm going to ask, before we get into the topic tonight, I have a couple of questions, some that I ask any astronomer that's on the show. But when a planet is locked, when a planet is locked like that, does it have like it's hottest at the equator, that type of thing? And then
it's hottest on the day side, at the center of the day side, which is permanent, facing the star, and then it's coldest in the opposite direction. And you should, in this case, by the way, the Proxima b, this planet, is moving around the star every 11 days. So if there are any living creatures there, they celebrate birthdays every 11 days. There are lots of parties over there. Another thing to keep in mind is the star is a dwarf star, 12% of the mass of the sun. So it's cool. It's about half the surface temperature of the sun, and it emits mostly infrared radiation. So we are used to visible light because our eyes were adjusted to the type of light that the sun produces. It helps us when it bounces off predators. We can escape from those predators if we have eyes that are sensitive to visible light. So for survival, our eyes adapted to the light that our sun produces. So next to Proxima Centauri, any creature would have infrared eyes. And that may explain why they never visit us, because interstellar tourist agencies that are looking for destinations will never find the Earth as attractive, because the visible light that we have here hurts the eyes of those creatures that have infrared eyes. And also our grass is green in the vacation sites that we can offer, whereas they are used to dark red grass. So that may explain why they never visit us, and we have to go there and entice them with a water-based drink.
Yeah, there you go. Now, what about in a situation like that, would it create strange weather patterns to have a locked planet like that?
Oh, definitely.
Where it's cold on one side and I think if they had an atmosphere and
it's quite unusual, because if you imagine life on such a planet, obviously the forms of life you have on the permanent day side would be very different than those on the permanent night side, and also the weather patterns will be quite different. And now we are not at all sure that such a planet can have life on it, because it's so close to the star that its atmosphere can be ripped by the stellar wind. So it's not at all clear that it could possess an atmosphere. And then, of course, if you don't have an atmosphere, as we know from the example of Mars, then you can't have liquid water on the surface of the planet. So, we are living on a planet around the sun, and that kind of a star is rare in the Milky Way galaxy. Most stars are like Proxima Centauri, and maybe there is a reason for that. Maybe, if you're too close to a star like Proxima Centauri, then a planet cannot maintain its atmosphere. You can't have life. So we don't fully understand how easy it is to live around the dwarf stars.
Right. There's so many different variables that can make whatever grows, if there's life there, the evolution of that life be so different, in so many ways, I would think. But so the question,
I think, just as a general, I was asked many times, how do I envision other forms of life? And when we meet another person that we've never met before, we can pretty much anticipate that the person looks like us because we share a common genetic heritage. But when we meet life from another planet that had no contact with Earth, I'm not talking about Mars that exchanged rocks with Earth, but a planet very far away of another star, it could be shocking for us to see what that life is, because you can start from the same chemicals and then end up in a very different product. Just like when you open recipe books for cakes, you can start from the same ingredients, and depending on how you mix them and how much heat you apply, you get very different cakes.
Right. Is bipedal optimal? And I don't know, you call it binocular vision, whatever you call it when you have two eyes. Is that optimal? I don't know. It depends on the
one eye, because it gives you three-dimensional vision. But the three eyes would have been even better, because then you can see back.
Yeah, there you go, for predators. So the question I'd like to ask astronomers on this show is, and I know you have an open mind, but I may be asking you to for your opinion. You may not want to give that, but do you think it's possible that the Big Bang Theory is something and it is flawed?
Well, clearly the Big Bang Theory is not complete, because we don't know what happened before the Big Bang. The Big Bang, is simply a point in time. If we go back in time, we see forward with time, we see the universe expanding. So we go back in time and the universe was contracting, and there is a point in time when the density of matter was infinite, and that we call the Big Bang. And the problem is that Einstein's theory of gravity breaks down at that point in time, because the curvature of space and time diverges, becomes infinite, and the theory breaks down. And we understand why it breaks down. It's because it doesn't incorporate a very important pillar of modern physics, which is called quantum mechanics. So we can't really tell what happened before the Big Bang. And so right now, the Big Bang Theory is really incomplete, and we don't know exactly what happened around that early point in time. And it would have been nice to figure it out. Just as a thought experiment, let me mention one possibility. Imagine that we had this theory of quantum gravity ourselves. Then we could have, in principle, created a baby universe in the laboratory. And then if we were able to do that, you could imagine that perhaps the Big Bang started from another laboratory of another civilization. So just like humans have babies that have babies that have babies, you can resolve the issue of the Big Bang by connecting the umbilical cord of our universe to a laboratory of another civilization that existed before us, and so forth. And, that's one possibility.
Wow. Yeah. And the other thing about time, did time begin then, or was there time before that?
So the problem is, as I said, our current theory, which the prevailing theory is Einstein's theory of gravity, is incomplete. And as a result, we can't really say much about what was happening around the Big Bang, because we know that quantum mechanical effects were really crucial at that time. And we don't have a good theory of quantum gravity. There are attempts to do that, but so far they were not very predictive as to what happened around the Big Bang. So, the nice thing about science is that you're allowed to say, I don't know. That's a valid answer. If you just don't know, you can say, I don't know. In other areas, for example, in politics, it's not common that a politician would say, I don't know.
That's true. Now, you were on the chair of the advisory board for is it called the Breakthrough Starshot? Is that what it was called?
Right, yes. Mm-hmm.
And Stephen Hawking was involved, and Yuri, I think he was involved, was he?
Well, so
in some part of it.
Sorry. Back in May 2015, a black limousine parked in front of the Center for Astrophysics at Harvard University, and out of it came Yuri Milner, an entrepreneur from Silicon Valley. And he came to my office, sat on the sofa in front of me, and asked me, am I interested in leading a project to visit the nearest star? And I knew that star is 4 light years away. So it takes light 4 years to get there, or to get from there to us. Only now anyone there gets the signal about the 2016 elections in the US. It's really a long time. So I realized he wanted the travel to take a couple of decades within his lifetime, which is roughly my lifetime. We're the same age. And so I realized that's a challenge because you need a spacecraft that moves at a fifth of the speed of light, which is roughly 1,000 times faster than all the rockets that we have sent in our history. So I told him I need to look into that, and then came up with a recommendation to use one technology that can potentially work, which is a sail pushed by light. So just a very thin piece of material, like a sail on a boat, except that it's being pushed by light bouncing off it. And the idea is to use a very powerful laser, about 100 gigawatt, that is focused on a sail the size of a person, roughly, that weighs about 1 gram. And then this sail would reach a fifth of the speed of light after a few minutes, across a distance that is 5 times the distance to the moon. And that was the concept that we came up with. And then Stephen Hawking came for the public announcement of this project in New York City.
I see. I have a couple questions about that, because I'm just trying to figure out how these things work. And maybe I'm picturing it totally wrong, but I'm picturing that this laser has to stay on the sail, or does it blink on and off? It stays on.
Well, it stays on it for a few minutes, and then the sail at 20% the speed of light will take 20 years to reach the destination of the nearest star. So it's a very short period of time during which the sail is being pushed by the laser, and then after that it just coasts.
So it's only one time that the laser hits this. Because I was wondering how you could possibly hit it once it started traveling.
Yeah, only when it starts, because the point is it's difficult, it's impossible to focus the laser at great distances. You can't really focus it on the sail. So you can do it on the sail only within a limited distance, and that's what dictates the power of the laser. If we could have focused the laser forever, then you wouldn't need very powerful laser. You could still continue to push it for 20 years. But instead, you need to push it only across a certain distance, and that distance is the distance over which you can focus the laser.
Another question I had about this, because I did a little bit of reading when the idea first came out, and how many of these solar sails would be sent, approximately?
You can do one a day, because the actual sail is really cheap. I mean, it's the cost of a cell phone. But most of the investment of funds is in the infrastructure of the laser and the spacecraft that releases those sails. But each sail is really cheap. So it's a change in concept that each mission that you send, each spacecraft, is very, it does not cost much, and you can do it once a day.
And so, say in 20 years, these reach that star system, how do they signal back? I mean, doesn't it take that long to come back? I mean,
well, it takes 4 years for the signal to come back.
I see.
That's the speed of light. But you are right that it's a great challenge. The communication across such a vast distance is not simple, and you need a big telescope on Earth to collect the signal that comes back and to read it. And the idea is to take a photograph of that planet and see what's on it. Now, of course, the same spacecraft can be used also within the solar system, much shorter distances. We could visit Pluto within a few days instead of 9.5 years that it took the Horizon to do it.
Yeah.
And so you can imagine a lot of other targets once this technology is available. We could have chased Oumuamua and taken a photograph of it easily. But with current rockets, we could not do that.
Right. And Oumuamua is still in our solar system, but heading out?
Yeah, it takes it about 10,000 years to traverse the entire solar system. So coming in was 10,000 years, now it's going out.
Wow.
But it is far enough for it to be extremely dim. It's now 1 million times fainter than it was close to the sun. So we cannot really observe it with any telescope. We had our chance, but we shouldn't worry about it too much because, when I go to the kitchen and I see an ant, I get alarmed because I know that there must be many more ants out there. And the same with Oumuamua. We found it over a few years with the Pan-STARRS survey telescope, and we should find a similar object every few years with Pan-STARRS. But in fact, in less than 3 years, the Vera Rubin Observatory in Chile will become operational, and then it will be much more sensitive than Pan-STARRS, and we could find an Oumuamua-like object every month. And my point is, if we find weird objects, as weird as Oumuamua was, we should contemplate sending a spacecraft with a camera that will intercept its trajectory and come very close to it and take a photograph, because they say a picture is worth 1,000 words. Actually, in my case, a picture is worth 66,000 words, the number of words in my book.
I got it. If this could possibly just be happening, but we didn't have the technology to see it until recently.
Right. Yes. So in fact, there should be a lot of these objects in the solar system right now. About a quadrillion of them, 10 to the power 15. There should be one such object for every volume associated with the orbit of the Earth around the sun, roughly speaking. So, there should be a lot of them, and we didn't have a survey telescope like Pan-STARRS until it started operating. Pan-STARRS was initiated because Congress gave a task to NASA to find 90% of all the near-Earth objects bigger than 140 meters, roughly the size of Oumuamua, that are coming close to Earth. Because we know that, 66 million years ago, there was a giant rock, roughly the size of Manhattan Island, that got bigger and bigger on the sky, and the dinosaurs saw it coming, but they couldn't do much, even though they had huge bodies. And then once it hit the ground, the fun stopped, and 3/4 of all life forms perished at that point, went extinct. And we came to the scene afterwards. So perhaps we owe our thanks to our gratitude to this giant rock that killed the dinosaurs and other forms of life so that we can come into the scene. But at any event, we don't want it to happen to us. So that's why the US Congress tasked NASA to find actually objects down to 1% of the size of the Chicxulub impactors that killed the dinosaurs. Pan-STARRS was designed to survey the sky and look for such objects, and it's doing part of this task. But the Vera Rubin Observatory will find 60% of those objects bigger than 140 meters that will come close to Earth. So it will go 2/3 of the way towards fulfilling the congressional task.
I think that's great. I mean, we need, I don't know if there was nothing we could do if something was coming at us. Hopefully we'll have technology to do that, or hopefully we'll get off planet and be able to not be completely wiped out if something like this happens.
You see, the remarkable thing is the human brain is so small compared to the size of a dinosaur. Nevertheless, it's much more important for survival. And that's why intelligence is so crucial. And that's why science is really our best protector, because it allows us to design telescopes that will alert us about an incoming rock, and so that we can deflect it. The dinosaurs didn't have that capability.
Yeah. One thing, I heard you say that with our current telescopes right now, we could probably see a city the lights in the city the size of Tokyo in our solar system. The question I have for you, the James Webb is going to be launched in October coming. And I actually had the pleasure of actually seeing that on site down there in Baltimore. But I just wondered if you knew if the James Webb will have the capability to see possible. I mean, can we see lights out of our solar system?
Well, a city like Tokyo could be seen 3 times farther with the James Webb Space Telescope. It has a larger mirror than the Hubble Space Telescope by a factor of a few. And so altogether, it can see something that is fainter by about a factor of 10. And I did this calculation about the city of Tokyo because I attended a conference in Abu Dhabi, and the tour guide was bragging that you can see the lights over there from the moon. And it was just a fun calculation to figure out how far away one can see Tokyo, from Earth with the best telescopes we have. And turns out you can see it on Pluto, for example, at the edge of the planetary array of, within the solar system. And of course, if you have many cities, then you can see farther out. So, for example, if Proxima b on its dark side has a lot of city lights that are illuminated by electricity produced by photovoltaic cells that are on the day side, you can imagine transferring electricity to the night side and illuminating it. Then we could, if the illumination is more than a few percent, this is actually a paper that I'm writing right now with an undergraduate student, then you could potentially see it with the James Webb Space Telescope. So your question is very timely because we are working on a paper related to that.
Wow. The work you did with the Starshot or doing, did that influence your thoughts on this Oumuamua?
Well, obviously it expanded my imagination. We can imagine only things that we know about. You can see it throughout the search for intelligence in the universe because we started searching for radio signals as soon as radio communication was developed here on Earth and radio telescopes were developed. And we started searching for laser signals once the laser was invented and so forth. And obviously the fact that I had some experience and knowledge about the light sails expanded my imagination. So actually at the same time that I worked on the Starshot concept for Yuri, I also wrote a paper about with a postdoc of mine about the fact that if there happens to be a beam of light propelling a light sail in another planetary system, let's say in an analog of the Earth-Mars system, and we happen to be along the line of sight of that beam, then as it sweeps across the sky, we would see a flash of light because of leakage of light on the boundary of the sail. So if you imagine a sail being propelled from an Earth-like planet to a Mars-like planet, you can tell when those two planets line up with our view, with our line of sight. And if you see a flash of light at that point in time, then you know what it may be used for. And that's a paper that we wrote when we were preparing the concept for Yuri.
Ah, I see. Well, I remember when I very first heard of Oumuamua, and I had a hard time saying the name. Sometimes I still mess it up. But all the depictions, and I did put it in your thumbnail too, because I couldn't really find the what I want to talk about. And this is your thumbnail right here. Mm-hmm. Everything you find online is a cigar shape.
That's right.
But when I'm reading your book, I find out that 90% of a chance that it's more like a flat shape, possibly a disc shape.
Yes. I mean, the reason for the confusion is simple. Just imagine a piece of paper tumbling in the wind. So Oumuamua was tumbling over 8 hours. And when you look at the piece of paper projected, you see something elongated. And that gave rise to the notion that it's 10 times longer than it is wide when projected, because the amount of light that was reflected from it was varying by a factor of 10 as it was tumbling. But that's just projected on the sky. It was 10 times longer than wide. Intrinsically, it was just like this piece of paper. And you can figure it out by modeling the variation in the light. So that was done in a paper that was published only in 2019. And before that, even the discovery paper of Oumuamua was pointing out that the flat shape is more likely based on what they saw. But that was just preliminary analysis. And then, the person that made this cartoon didn't really pay attention to the details. I'm not sure exactly why, but made it look like a cigar. But the reality of the situation is that already discovery paper pointed this out, and then there was a detailed analysis published in 2019 that showed that it is at the 90% confidence level, pancake shape.
Right. And it has, I know you said it has something like 6 very strange properties.
Right.
So I want to get to all of them. But before we do, I just want to take a little jag here and just ask you, someone at your level, what type of ridicule are you getting from your colleagues and people in the science world?
Well, I should say it's significantly muted by the fact that, I had a lot of leadership positions, and many people know me, and that I worked on topics ranging from the early universe to black holes. And, I applied exactly the same approach to this subject as I did to other anomalies in other contexts. And so, I keep my eyes on the ball, just like basketball coaches advise players to do. I don't care about the audience, and I'm just talking about the evidence. And I highly respect those scientists that try to explain the same evidence, which is anomalous, in terms of a natural origin. I have no problem with that, as they put some possibilities on the table and we can discuss them. Unfortunately, all the possibilities that were put on the table as a naturally occurring object, all of them involve something that we have never seen before. And all of these possibilities have major flaws. I can give you some examples. One was that maybe it's a hydrogen iceberg, a chunk of frozen hydrogen the size of a football field, because we haven't seen a cometary tail, and no tail of gas or dust was found around this object. Even with a Spitzer Space Telescope that looked very deeply, couldn't find any carbon-based molecules. And the idea of the hydrogen iceberg was that, the hydrogen is transparent, so you might get a cometary tail without seeing it. But then we showed in a paper after that, in fact, a hydrogen iceberg would evaporate very quickly. It wouldn't survive the journey because it will absorb starlight. So that doesn't really work. And then there was a suggestion, maybe it's a cloud of dust particles, sort of a very fluffy cloud of dust that is 100 times less dense than air on average, like a dust bunny. And the problem of that is when it gets close to the sun, it will be heated by hundreds of degrees, and then it will lose its integrity because it doesn't have the material strength to survive. So, and then there was another idea that maybe it's shrapnel, some fragments from the disruption of a bigger object by a star. And the problem with that is that a tidal disruption of an object results in elongated pieces, and the most likely model for Oumuamua was flat, a pancake shaped. So all of these suggestions, and these are the only suggestions put on the table to explain the anomalies. And all of them involve something that we've never seen before. And all of them had flaws. And I said that, if that's all the alternatives we have, we should definitely seriously contemplate the possibility of an artificial origin. And of course, there was a huge backlash against that possibility. Most people did not attend to the anomalies. They just didn't want it to be on the table because it takes them out of their comfort zone, And there was a seminar at Harvard about Oumuamua, and when I left the room with a colleague of mine that worked on rocks for decades, he said, this object is so weird, I wish it never existed. And to me, that was appalling, because when nature gives you evidence that is not lining up with what you expected, that's actually an opportunity to learn something new. And you should actually be thrilled at such an... But somehow, many of my colleagues prefer science to be boring, not to be exciting. And I don't fully understand that. And, one possible reason is they worry about their reputation. They don't want to take risks. They don't want to put any skin in the game. But that goes contrary to innovation in science, because, just like kids, you have to put skin in the game, because otherwise you don't learn anything new. Einstein was wrong 3 times in the last decade of his career. He said that black holes don't exist, gravitational waves don't exist, and quantum mechanics doesn't have spooky action at a distance. And all 3 were proven wrong by experiments that took place later. But that's fine. When you work at the frontier, you make mistakes sometimes. However, if your objective is to always be right, then obviously you would retreat to a place where you never put skin in the game, you never take any risks, you always sit in your comfort zone. And I mean, you can get awards and honors and belong to honor societies, but frankly, I would hate to be in that position because that's boring, and science is supposed to be exciting. Why should we retreat to a place that is so boring? And especially given that the public is excited about this question of, are we alone? Are we the smartest kid on the block? So, and the public funds science, and I think scientists have an obligation to address this question if they have the ability to do so. And we certainly have the telescopes. It's just that this kind of a search is not funded much, and there is this ridicule of any suggestion in this direction that I find inappropriate. Some scientists say, well, it's a controversial subject. My answer to that is, if you go to ancient times, there was a controversial suggestion that the human body has a soul. And imagine if scientists would say, there is this controversy about whether the human body has a soul, and therefore we don't want to pursue anatomy because that there are some views that say that it should be forbidden, and other views that say, no, you should actually dissect the human body to find what's inside. And imagine where modern science, modern medicine would be if we were to avoid this subject just because it's controversial. I think there is an obligation for science to clear up questions of great interest to the public using the scientific method.
As I said in the beginning, I think since human existence, there's been pushback on something new, and it's got to be fear-based. Fear and ego. I don't know what else.
Right. I agree.
Like I should know about it, that type of thing. We're having a number of things come into the chat as far as questions. I'll just pull one up here because I think you can address it. Don is asking, if Oumuamua was a scout ship, how much information could they have collected about Earth? Or I'll just add to that a little bit. If it was, would they even want to? Are we that special?
Well, that's exactly my point. I don't think that we are sufficiently interesting for anyone to worry about us. We had our technologies only for 100 years, about a century, and Oumuamua started its trip into the solar system 10,000 years ago, when we weren't very interesting back then, technologically speaking. And therefore, I don't think that it is likely to be spying on us. The more likely situation is it's a piece of equipment that was produced billions of years ago, because most of the stars in the Milky Way galaxy formed billions of years before the sun. The sun is a latecomer. And so if those stars had civilizations like ours that sent probes into space, like Voyager 1, Voyager 2, New Horizons, these probes billions of years later are not operational anymore. But, they are just like plastic bottles on the beach. They may have punctures in them, and they're not really functional, but they tell us a story about a civilization that made them. And the best way to tell that it's not a natural object, not a rock, is to take a close-up photograph and then decide whether we want to land on it and put our hands on this piece of technology, because perhaps it's 1 million years more advanced than the technologies we have right here, right now.
Yeah, and you mentioned in your book, and I sent you an email about this too, that I had an astronomer on my on this show before, who basically said that his fellows at NASA agreed with him that if a civilization can get through the bottleneck of technology without blowing themselves up, they'd be traveling the stars. But along that same line, and you kind of touched on that in your book, along that same line, it's possible that these billions of year old planets have had multiple civilizations that might have wiped themselves out and started over again. These things are all possible.
Definitely. We had a lot of cultures on Earth, and we can't have a phone conversation with the Mayans. The Mayan culture is gone, and but we can find about them by looking at the relics they left behind through archaeological sites. And that's why I think the biggest message of Oumuamua is space archaeology, because it allows us, to search for relics left behind by dead civilizations in space. And in the past 70 years, we've been looking for radio signals, but it's just like a phone conversation. You need the counterpart to be alive. And if most counterparts are not alive anymore because they predated us by billions of years, then searching for relics that they left behind is a much better approach. And if I had funding, what I would fund first is placing cameras within the orbit of the Earth around the sun so that they could look up close at interstellar objects that come into our neighborhood and see whether there are rocks, natural objects, or plastic bottles, artificial objects. And this I would call space archaeology. And I think it's a new frontier that should be mainstream, just like archaeology on Earth is mainstream. And on every campus, there should be space archaeologists.
Wow, how about that? That's a great thought. The one thing that when I first read about Oumuamua, the first question I had is, how do we know it's from another solar system? And I know I do know this now, but I want you to explain that for the person that may not.
Right. So that is relatively straightforward because the object was moving very fast and it could not be bound to the sun like the planets are. The Earth is bound to the sun. So when we launch a rocket away from Earth, if we give it a high enough speed, it will escape the gravitational pull of the Earth. If we throw a stone up, it comes back to us because we don't throw it fast enough. So clearly, the speed of an object can tell you whether it's bound by the gravitational force to Earth or to the sun. And Oumuamua was moving too fast to be bound to the sun. Now, that's another weird property of Oumuamua that when you ask where was it before it arrived to the solar system, turns out that it was at a special frame of reference called the local standard of rest, which is the frame that you get to when you average over the random motions of all the stars in the neighborhood of the sun. And it was at rest in that frame. So it was sort of parked in the local parking lot, not moving, like a buoy on the surface of the ocean. And then the solar system, like a giant ship, bumped into it because the sun moves relative to the local standard of rest. And only 1 in 500 stars is so much at rest in the local standard of rest as Oumuamua was. So the question is whether that tells us something about the purpose of Oumuamua. Perhaps it's a member of a grid of objects that are filling up interstellar space, just like coordinate posts. And so that when you travel through interstellar space, you know where you are relative to these objects that are at the local standard of rest. Or maybe it's a member of an array of objects that are used for relay stations for communication. That could be two possibilities, given the fact that it's so weird in terms of where it started from.
Now, the speed thing, I'm still stuck on that just a little bit, because a lot of times you hear like an asteroid's moving like 40,000 miles an hour or something like that. I think, did I hear this was 60 or something like that? I'm not sure. But my question is, because of our solar system, do we have a speed limit in our solar system?
Yeah, no, I mean, so an object that comes from almost at rest, bound to the sun, like at the edge, the periphery of the solar system. In fact, there is this Oort cloud of objects where they hardly move relative to the sun. And if one of these objects just falls towards the sun, that will give you the highest speed that a bound object, an object that belongs to the solar system, can move relative to the sun. And Oumuamua was moving faster than that because the solar system was actually moving relative to the local standard of rest and bumping into it. So think about this object being at rest, like a buoy on the surface of the ocean, and then the sun, just like a giant ship, running into it at 20 kilometers per second, or like about 15 miles per second, just bumping into it. And obviously, it's not bound to the sun because it was separate from the solar system to start with, and then the sun is moving relative to it at a large distance until it runs into it. And so that's from the point of view of Oumuamua, seeing the sun approaching it. But from the point of view of the sun, Oumuamua is approaching it. So it doesn't really matter which frame you're sitting in. You just see the same motion, but the reflex of the same motion in the two frames.
Now, when this thing went by the sun, there was no apparent outgassing, which was another odd thing, right?
So then it meant that it's not a comet, because comets show very clearly evaporation of gases. And in fact, the second interstellar object that was discovered by Gennady Borisov, a Russian amateur astronomer, which is called Borisov after him, did look just like a comet. And so people ask me, oh, obviously Borisov is a natural interstellar object. And I agree with that. And then they said, doesn't it convince you that Oumuamua was also natural? To which I replied, if you find a plastic bottle on the beach and after that you find rocks, it doesn't make the plastic bottle a rock. Or another way to put it, when I met my wife on the first date, she looked special to me. The fact that I met many other people afterwards didn't change this perception. So, in fact, since Borisov looks natural, then it makes Oumuamua even more strange.
Right. And also, it picked up speed, as if like the sail theory again, right? After it went by the sun.
Right. So there was an extra push away from the sun, and so that the only plausible interpretation, as far as I'm concerned, was that it reflects sunlight, and as a result, it's getting pushed. And for that to be effective, it had to be very thin, like a light sail, and so that it has enough area for its weight to be pushed by reflecting sunlight. And in September 2020, there was another object discovered that also exhibited an extra push by reflecting sunlight and didn't show any cometary tail. It was given the name 2020 SO by the organization that gives names to celestial objects, the Minor Planet Center. And then it was discovered by Pan-STARRS, the same telescope, and the astronomers figured out that actually it originated from the Earth. In 1966, it was a rocket booster of a lunar lander mission that was kicked into space. And obviously we know that it was hollow and had very thin walls, and that's why it was pushed by sunlight, because it had a lot of area for its weight. And so we know that this object was definitely artificial because we made it. We don't know who made Oumuamua.
Now, as far as trying to figure out the aspect ratio, this thing you said it's just under 8 hours. I guess it's rotating. But this is all theory. There's no real way to tell an aspect ratio of.
Oh, no. So what you can argue is that the amount of light that we receive is simply the area that the object projects on the sky, because we see reflected sunlight. And so variation by a factor of 10 means that the area of the object projected on the sky changes by a factor of 10 as it's tumbling. Unless, of course, the reflectivity of the object also changes. But if you assume roughly the same reflectance across the entire object, then it means that the area of the object changes by a factor of 10 projected on the sky, just like a tumbling piece of paper in the wind. And that implied that it has an extreme geometry. We don't see that often for rocks. At most, they show a factor of 3 variation. And then, of course, there was this fitting to the light curve that implied that it's probably pancake shaped, flat.
Now, I'm going to ask you an uncomfortable question.
Go ahead.
This is a show about UFOs, and there has been a lot of people, including the Navy and pilots and things like that have UFO sightings. Do you think it's out of the possibility that perhaps they have figured out how to get here?
No, I don't think I don't think we should have prejudice. And in fact, I have a Scientific American essay on this subject from yesterday. So check it out.
Oh, wow.
And My point about the UFO reports is as follows. I mean, there is also, everyone is anticipating for the declassification of the Pentagon documents, but I'm not that obsessed with old reports because they rely on eyewitness testimonies and on equipment that used to exist decades ago and was not optimized for that purpose. And I would much rather see funding of a scientific experiment, basically, of using state-of-the-art cameras and audio sensor and placing them in the same locations where the reports came from, the most credible reports, and just recording everything out there and looking for anything unusual. And I think that would be the best way forward, because you never know whether, what happened decades ago. And why should we obsess with that? Science is about reproducibility. And if we place state-of-the-art cameras and audio sensors, we will get much better data, and then people will be convinced about it. So that's my hope, that such an experiment will be funded. And I always give this example of, the biblical story of Abraham that says that Abraham heard the voice of God and that told him to sacrifice his only son, Isaac. And if Abraham had a cell phone with a voice memo app, he could have pressed the button and recorded the voice of God. And then everyone would believe his story. But since he didn't have a cell phone back then, we have to decide whether we believe Abraham. So my point is that scientific instruments remove the concerns that some scientists would have with eyewitness testimonies. And we should deploy the very best instruments we have right now at those locations and see what they record. That's all.
I love that. I love that answer. That's a great open-minded answer. And Marc D'Antonia has actually been involved in something. We'll bring him on in a little while to talk about that. But along those lines, with sophisticated equipment, and his partner on that is very well funded. But I think there are countries that are taking this serious. Chile, for one, they do, and I know there's great telescopes in Chile, but their whole entire government is involved. Even the police and military, everything is in looking at it seriously. One
reason for governments to be concerned about such reports is, of course, national security. You might want to know if other nations have technologies that you're not aware of, and they're used for espionage. So that's why governments are interested, but it's a completely different reason than the scientific reason of trying to find evidence for alien civilizations.
Yeah, that's great. We are going into break in just a minute. I did have another question for you here before we go in. And Karen Meach, Professor Meach, she kind of disagrees with you or not? In your theory, I did see her name come up.
Well, I think she is playing the conservative mainstream approach, saying that extraordinary claims require extraordinary evidence. And my answer to that is that extraordinary conservatism leads to extraordinary ignorance. The point is that we should be open-minded, and when there is anomalies, we should invest in getting more evidence to find out what their origin is. And the alternatives to my artificial origin invoke something that we have never seen before. So obviously we will learn something new, irrespective of whether it's a natural object or an artificial object. And the only way we will not learn anything new is if we believe everyone that says it's just rocks, it's never aliens.
Yeah.
And if we adapt that approach, we will be very similar to those philosophers that refused to look through Galileo's telescope.
That's right. And how we stand still so many times. That phrase from Sagan was originated all the way back in 1814 and then reinvented in 1899 as this: the weight of evidence for extraordinary claim must be proportioned to its strangeness. And that was by Theodore Flournoy in 1899. So it was Carl Sagan kind of remade that saying, but it holds true all the way through.
Yeah, I should also say that the existence of aliens, I don't regard it as extraordinary, because we know that we exist. We know the conditions on Earth are reproduced in billions of Earth-Sun systems throughout the Milky Way galaxy. Why should we believe that we are unique and special? That would be arrogant. And I think the mainstream conservative view, that is also a matter of common sense, would be to say that things like us are very common, and we should just search for them. That should be the mainstream view. So I wouldn't call it extraordinary.
Right. All right, Avi, we are ready to take a break right now. Thank you. And we'll be back in about 3 minutes or so. So everyone, hang in there. I'm going to be right back with Marc D'Antonia. We're going to talk during the break and bring our guest back in right after the 3-minute break. Hang in there. Hello, Marc.
There we go. I had to unmute. I know it mutes automatically, but you know what? I never know.
Well, I can always mute you if I want to.
This is good. I mean, I rephrased some of my questions because he answered some, and I wanted to, I think that he and I meet in a lot of ways on this. I'm really, really excited to hear what he had to say.
Good.
He and I did an ABC special with an ABC affiliate in Boston. Okay, it was Chronicle, and we didn't meet on that shoot, but he did his from where he was, and Doug and I did ours from Doug's studio, and we talked about the prospects of alien life being here. And I think it's important to maybe we can talk about this too, bring up the fact that I think that if they're here, they're not going to be hiding on the moon. They're not going to be watching us from some Lagrange point somewhere. I think they're going to be in our oceans. They're going to be deep in the oceans because we're not there. They go where we are not, basically, kind of a thing. If they're here, I mean, and you can't just say something with absolute like that, like oh, they're here. No, we don't know that. They may be here. There's a possibility. And as he said, mainstream science can't deny the possibilities, and mainstream science shouldn't close their minds, because as he said, extraordinary, proof might be required, but you can't exhibit extraordinary ignorance by ignoring other things.
Yeah.
And that's very true. And that's how I live my life. That's how I do things. That's why I'm open-minded.
Well, yeah, what you said about the ocean, think about how much of the ocean covers this earth. And we know less about the ocean floor than we do about the surface of the moon, from what I've heard. I don't know.
Right. You go into Google Earth and you think, wow, look, you see the whole ocean floor mapped out with that bathymetry. You see all the ups and downs, all the levels, changes, you see all that. But you know what you don't see? You don't see a snapshot of what it is right this second. You see the bathymetry of where that towed sled went over the bottom to show you that ocean floor at that time when they did it 7 years ago, say. It didn't happen all at once. It took years to map the ocean floor like that. So when they did that, that's just a snapshot. And you can be sure that certain areas look very different now than they did then. And even within the range of all that data, certain parts of the ocean floor are going to look very different from the ocean floor now. So it's a constant change. So we have to be careful not to accept everything we see as this is absolute truth right now, because it's not.
All right, gentlemen, we are coming back in about 5 seconds. Stand by. In 3, 2, 1, go.
All right, welcome back. Just brought in Marc D'Antonia and bringing back on our guest, Avi Loeb. We're all three here together. And so, Marc, you just mentioned during the break that you were in the same location on a shoot at the same time as Avi was.
Yeah, sorry. Yeah, you remember I don't know if you remember this, Avi. We did a ABC affiliate show, Chronicle.
Oh yeah.
Yeah, you did your part. We did our part. Uh-huh. Okay, we were in Western Massachusetts, and you were in over in Harvard, which I thought was pretty funny.
Yeah, it's very close, and I remember that show. Yeah.
Yeah, and it was a very good shoot, and one of the things I thought about, which I wanted to ask you about, and congratulations on the book.
Thank you.
Excellent. Okay. I think more of it is needed, frankly. And what happens is when we look in our vast oceans, right? My feeling is that and I say if, okay, because I'm a science guy, you say if, right? You don't say definitely. You can't use authority. We know that, But the thing is, if they're here, all right, then I have a feeling that they're observing not from the moon, not from some Lagrange point with a cloaked spacecraft, not via the SOHO, and looking at all those cosmic ray flashes on those photos, okay, but perhaps from within our own oceans where we are not. They go where we're not if they're here, right? I mean, doesn't that seem like a logical approach?
I think we should contemplate all possibilities. This is one of them, and definitely worthwhile. The question is, can we do experiments that will let us know about them?
Yes, we can, and that's something that we've been working on. Actually, we've been working on a very type of technology to allow us to look not up but down in the ocean, using technology to see what might be under the water. And maybe some hot spots that people say, oh, well, we see all these funny lights coming out of the ocean over here. Well, let's deploy something. I came up with a system that we haven't built it yet, but it's actually it sits in the tide, it sits in the waves, and it uses the wave action to charge its batteries. It's one of these little dipping things that actually starts to do these self-recharge as it dips. It's not an uncommon thought. And so, but it would look down with instrumentation. With instruments that can actually penetrate through the water. Obviously, we know sonar can do it. We certainly can't. There's certain light we can't use.
By the way, I mean, whatever you find would be interesting, irrespective, because you will do the first observations of such environment.
Right.
Yeah,
that's right.
Mark, Mark,
Go
you would tell them what you and Doug were putting together.
Yeah, well,
for UFO technology observation.
Right. And one of the things that I feel is very important is trying to, use science to determine if they're here. Let's get the answer. Let's figure this out. There should be a way, right? You're looking at Oumuamua. You're saying it's a pancake-shaped object. This might be a very, very thin light sail technology, which, by the way, Douglas Trumbull is a big fan of, just so you know. Okay. And this light sail technology is something that you've identified as a very strong possibility. But here on Earth, how can everyone participate in finding such things? Well, the way they can is if we can make these what we call platters of instrumentation that are always looking up and observing the sky, but not with just regular cameras. They have to look in the wavelengths that our eyes don't use, obviously. They have to look at other energies that are being given off by potential interlopers into our space or whatever. And, you quickly start sounding like some kind of a UFO nut when you start talking about this stuff. But it's just science, trying to find out what other things are in play in our atmosphere.
So did you deploy instruments of that type? Or?
Not yet. Actually, there was a prototype that was made, yes, but there was only one.
Okay.
And we actually cannibalized that, and we're making our others, our other platters.
No, that's exactly the approach that I'm advocating for, and I wrote about it in Scientific American, basically making it a part of science and trying to figure out, try to collect the data and see what we get. And I think it's a much healthier approach than relying on old documents, because we can design the experiment to be optimized for this purpose.
Yeah, I agree with that. And the other thing too that I've thought of and said many times is, and you probably will agree, is that, and you actually do agree, I know. I don't really care about historical UFO cases. Okay, as you said, and you point out very eloquently, it was taken with old instrumentation that didn't pass the scrutiny, that we would put it under. And therefore, it's not going to be valid to me. I only focus on now and the future.
Right.
Because now in the future, we have the best technology to use, to look at.
That's exactly, you're saying exactly what I said. Yeah.
Excellent.
I completely agree with it. Yeah.
Yeah. I'm there.
Mark, you're going to have to turn your headset down a little bit more again. Unfortunately, it's feeding back a little bit.
Okay.
I sent you a message, but you didn't see it.
I did.
Yeah.
Maybe like this.
That should be better. Yeah.
Okay.
Yeah. So, Mark, what is a really good question to ask Avi now that you have this opportunity?
It's something I've actually wanted to ask you. I actually wanted to ask you this when we were doing the shoot, and I was hoping that we were going to be in each other's presence so I could talk to you about this stuff.
Go ahead.
But no, they didn't do it the way it worked out. I was really interested in the fact that Oumuamua shows us this dichotomy of two different potential objects. On one hand, it looks like it's a comet. On the other hand, it appears like it's an asteroid. How do people in science actually sit there, look at this thing, and say, well, it's just a strange asteroid? I don't understand that.
That's a very good question because it did exhibit all these anomalies, and I think people just want to dismiss that it's strange, and they just say that and ignore the facts. And unfortunately, that's an acceptable behavior these days, even though, very often it's argued against politicians that are ignoring evidence, ignoring facts, that, how dare they do that? But if scientists can do it, why would we hold our politicians to a higher standard? But I should say it's not all scientists. Those that take seriously the anomalies and the facts, they're trying to explain them. And of course, there are some like that, and they came up with all these scenarios that I mentioned that involve something that we've never seen before. So that I actually regard with respect. And, it's just like the scientific process where you put all possibilities on the table and you collect more evidence, and that's completely legitimate. But, there are people that didn't write even a single paper over the past decade that would criticize my paper without a good reason, just because they don't like this notion, and it's an unfortunate symptom of social media these days that there is a lot of groupthink, and people encourage each other by making false statements that are not attending to the facts.
I don't disagree with that at all. I think that's a marvelous
it's a big problem.
Yeah. I look at life on Earth. We're bipedal. We have our binocular vision. Every life form has DNA. Okay. To me, that's a template that the universe provides, because there's so many variations of life on the planet that they had a chance to have developed, other types of life here. Maybe we can find other types of life that are very hardy microbes on Mars. I'm looking forward to that, actually. Right. Under the South Pole of Mars, there's a reservoir. Maybe we'll find life there.
That will be very interesting. And on Mars, of course, the fundamental question, if we find life, is it similar to life on Earth or not? Because if it resembles the DNA we have on Earth, then it may mean that life was transported with rock. We know that there are Martian rocks that arrive to Earth and vice versa. And it's quite possible that life was exchanged between the planets. We might be all Martians, for example.
Exactly.
But there is the second possibility that it will be completely different. And that would illustrate that not only there was no exchange of life, but also that there are multiple paths for having life. And either way, it would be very exciting to see evidence, because it would be a second data point, even though this is the nearest one of, the second nearest planet to us after Venus, that nevertheless, it's a second place where we might find life.
Yeah,
I'm gonna ask kind of a philosophical question. The first spark of life. How you think could ever be created in a lab?
Oh yeah, I mean, at Harvard, one of my colleagues, Jack Szostak, who is a Nobel laureate, is working on making synthetic life, basically a living cell out of scratch, and
wow.
He's getting close to that. He said that when he started to work on it about a decade ago, he was quite pessimistic and said that he cannot see how life formed spontaneously on Earth. But now he changed his view. He thinks that it's, once he started experimenting, that it is reasonable to have expected the Earth to produce the conditions that lead to life. And he's almost there. I mean, he's getting there, and he doesn't see any major roadblocks. So he's getting close to making synthetic life in the laboratory. It's not the same as the life that that form naturally, but it's the first step. If we are able to create a living organism in the lab, then after that we might design organisms that are not very different from what we found in early Earth.
Wow. What kind of award would someone get for that?
A Nobel Prize.
Yes, I would think so.
He's second if he's successful. Yeah.
Yeah. It would be such an amazing development, really.
I mean, have a question to ask if I could, Martin.
Yeah.
My picture is here. I feel I have a little bit of time to ask him a question or so.
Oh, yeah.
Avi, I wanted to ask you, Oumuamua had a really strange change in its albedo as it was moving through. And so the question I had regarded to that brightness change was, does that spin rate that it had say anything about its composition in terms of flying apart or being held together, whether it was metallic or not? I mean, I don't have good enough information about that.
Well, regarding the composition, there are two ways you can go at it. One is if you have a good spectrum of the reflected light from the object, then you might be able to infer what it's made of. But unfortunately, the spectrum was not high enough quality, and it just looked red, kind of reddish. And then you couldn't tell whether there are specific elements on the surface of this object. And then with respect to material strength, that really depends on its shape, which, I mean, we don't have an image of it. We just have, it just appeared as a point of light, and we know that it was tumbling over 8 hours. And any solid could potentially do that. That is not a challenge for an object the size of a football field to spin around every 8 hours. So you can't, I mean, even for a cloud of dust, it's possible. I checked the numbers. So that doesn't say much about the material composition. So obviously the next time around when we find another strange object of this type, we want to get much more data on it.
Yeah, and that's early detection.
Exactly. And the LSST on the Vera Rubin Observatory, this survey of the sky, would be much more sensitive than Pan-STARRS and could find objects much farther away. So it could give us an advance warning of a year or more of objects like Oumuamua. And then we can plan a mission that would intercept their trajectory so that we can get a photograph. I think that would be fantastic.
Yeah. I think that's wonderful. Absolutely wonderful.
So
Just
within our
question.
lifetime, we might know the answer. You see, that's the thing, that it's not the evidence would be the key.
A question that came in, and Mark, you're welcome to ask one right after this. But a question that came into chat was, is it possible the surface of whatever it was could have been a painted surface, so to speak?
Well, it's possible.
If it was artificial?
You have to realize that when an object is in interstellar space, it gets bombarded by dust particles and by gas. And actually, the objects that we find in the Oort cloud, in the outer part of the solar system, are also exposed to the same environment as interstellar space, because the solar wind is being stopped at 100 times the Earth-Sun separation, and the Oort cloud goes to 100,000 times the Earth-Sun separation. So most of the volume of the solar system is exposed to interstellar space in much the same way as an interstellar object is. And there would be damage to the surface of any object traveling for millions of years, just like the damage that is encountered by the comets or asteroids that are out there in the outer parts of the solar system. So I think if you were to take a close-up look at the surface, unless it's metal that is very resilient to damage, it would look pretty much like any rock in terms of being, bombarded by dust particles and having some small craters on it. So it will be a rough surface. And that's probably why it was reddish, similar to the colors of objects from the Oort cloud. But whether it's artificial or natural, you can tell that by having a resolved image, because you can tell the shape of it and the thickness of it. And, rock, it does not resemble a sail, for example.
Doesn't radiation also redden surfaces, or after billions of years, certain types of radiation, right? I mean,
yes.
So that's another possibility, right? For why that could be reddish.
It's radiation. It's also cosmic rays and bombardment by dust particles. Yes.
Mark?
Yeah, I actually, this is another one I thought of too, Avi. Which this is good stuff. What can I tell you? I mean, I really enjoy this. I could talk about this all night. Unfortunately, unfortunately for you,
I'm actually enjoying it as well.
Excellent. I felt that in our solar system, there were dynamical instabilities way in the beginning that ejected lots and lots of things, and they became interstellar.
Right.
And perhaps at some point they may end up at in the local standard of rest at some point and make their way into some other star system at some point.
So we actually wrote a paper a decade before Oumuamua was discovered in 2007 with Amaya Moore Martin and Ed Turner. That was the first paper to forecast how many interstellar objects you might expect as a function of size. Based on the ejected rocks from the solar system.
This is where I'm going.
And we found that the population that you will end up with will not be detectable with pan stars. It was 100 to 100 million times smaller than the population needed to explain Oumuamua as a member of a random set of objects. And so the answer is, even if Oumuamua is natural, the factories that make Oumuamua-like objects must be unusual. They cannot just be, planetary systems like the solar system, because when we did the calculation for such systems, there wasn't enough stuff. There weren't enough objects that could be ejected to account for the abundance of Oumuamua-like objects. And we can infer how many Oumuamua-like objects are needed because the Pan-STARRS telescope surveyed the sky for a few years and had a certain sensitivity. And so you can tell from the detection of one object how many more should exist. Just like going to the kitchen, finding an ant over a certain area of the cabinet. And then by knowing the total area of the cabinet, you know how many ants are out there, how frequently you would see one of them within that area. So it turns out that, the population is far greater than expected based on, and that's why I was interested in Oumuamua, because I didn't expect it to be found in the first place.
Oh, and of course, that's based on our solar system and how we evolved. But a more massive system, I mean, we found exoplanets that have multiple asteroid belts, for instance.
So Amaya Moore Martin actually my collaborator repeated that exercise after the discovery of Oumuamua and included all types of stars. And she still concluded that it's very difficult to account for the population of objects that would explain Oumuamua. Even if you sum over all types of stars and planetary systems around them. So
Gotcha.
It's enigmatic. I mean, as I said, you learn something new from these objects, irrespective of whether they are natural or artificial.
Sure.
Well, I have kind of a philosophical question.
Mm-hmm.
Most solar systems, I think I've read this, are binary. And I'm just wondering, would that make any difference, and this is an opinion, on evolution of living creatures, a binary system?
Well, so there is roughly, crudely speaking, there is equal probability for binary stars to be at the per logarithm of separation. So if you change the separation between the two stars by a factor of 10, you have roughly equal probability, every factor of 10. And that means that a substantial fraction of all systems will be separated by a large distance, such that it wouldn't affect the inner planets, like in the habitable zone around each star. So each star will have its own habitable zone, and the two stars will be separated by a large enough distance so that, it's as if you have two independent stars. But there should still be some where the two stars are close enough to affect each other's habitability. And that is a very interesting question, because the question is whether it will help or hurt the prospects for life. If you have two suns that are not very far apart, the other sun could, for example, disturb the orbit of the planet and not allow it to be circular in the way that the Earth is going around the sun. that would have implications for the possibility of life. But there would be another source of light, and I don't think this is worked out in sufficient detail. This is a very interesting question, and it's not that most stars are so close. I mean, it's a small minority, maybe 10% are close enough for the two stars to affect habitability of each one of them. But nevertheless, it's it's not a negligible fraction of all stars. So it's very interesting question. I should say also that a significant fraction of stars are in triple systems and quadruple systems. Stars, despite what there is a long tradition in astronomy of discussing single stars, but in fact, a significant fraction are in binaries, like half of them, and another quarter is in triple systems that have 3 stars, like. The Alpha Centauri system is a triple. The next, the one next door, the 3 stars closest to us are a triple. And then you have quadruples also, not, in a significant fraction of all stars. And the implications of that is not fully understood in the scientific literature, and it doesn't just affect habitability, it affects a lot of other aspects of the evolution of stars, because one star can affect the evolution of another, and it's still there is still work to do for younger people.
Right. Think about the 2 stars side by side at one point, and then one goes behind the other. Well, if you're in that same plane of the orbit, at this point you're getting a lot more radiation per square meter on your surface, and then here you're getting a lot less. So will that variation change the capability of life to develop? I mean,
that would be a very interesting thing to explore. Yeah, but think about how beautiful the view is to have 2 suns in the sky.
You can never sleep.
Sunsets.
Sunsets all the time, or is it rising? I can't tell. Yeah,
you call it a sun's set.
Yeah, plural.
Yeah, that's right.
So we can take calls starting fairly soon, but you have another question, Mark?
I'm actually okay. Well, we talked about the Ultima Thule in our Kuiper Belt, the Kuiper Belt object that New Horizons went to after Pluto, and of course that was a contact binary of 2 pancake objects, right? So I'm thinking how that's interesting, because if Oumuamua was really a pancake object, is it possible that Oumuamua was not from our solar system, but from another star system, but was an ejected, foreign Kuiper Belt object that actually was ejected somehow and came here? I don't understand the mechanics by that, because it would seem to be real traumatic for that to actually happen.
Well, so it couldn't have been a contact binary or two objects, because it was spinning around every 8 hours, and you wouldn't get that behavior given the tidal force from the sun. It would not work out. But in principle, we don't know where it came from, and the thing is that it came from the local standard of rest, and there is no star in that frame that we can associate it with. If it was, the most likely origin would be from an Oort cloud, because that's the place where most objects are loosely bound to their star, and you can rip them apart by a passing star. And but then they would share the motion of the parent star, and we haven't seen a parent star that shares the motion of Oumuamua.
Yeah.
What is a planetesimal ejection?
Planetesimal is just like a Lego building block of planets. So the way that planets are believed to form is that you have some debris from the formation of the star. Okay, so when the sun formed, it was a cloud of gas that collapsed and cooled and made the sun. Okay, but there was some debris left over from the sun, about a few percent of the mass of the sun. And that debris cooled and made a disk of material around the sun and was orbiting around. And then out of this disk of material, the heavy elements sunk to the midplane. And they started making dust particles, and the dust particles stuck together to make bigger and bigger objects. These were the planetesimals, rocks, that got bigger and bigger by sticking together, and then eventually the force of gravity bound them together to make rocky objects like this, like the Earth. The Earth is a rock, Jupiter, in addition to the rock in the interior, is the rock accreted hydrogen and helium and became a gas giant. But the initial building blocks are basically planetesimals. These are just like Lego pieces that come together and make the planets. And many of these Lego pieces were scattered around, and they make up today the Oort cloud. They are the rocks that existed early on and were scattered by the planets. And so by examining them, we can tell what the initial Lego pieces were.
I didn't even put up the phone number yet, but we have Kevin from Augusta, Georgia on the line. Kevin, welcome to the show.
Hey, Martin, how you doing?
I'm well. How are you? You remembered the number. How about that?
I did. Well, are you ready for my question?
Yes.
No. Well, I'm honored to talk with Dr. Loeb, and I have to, just comment a little bit how fearless his attitude is. I'm no scientist, but I work for the Department of Energy, and there's a certain amount of cultural inertia that goes on with science. And so I just like to hear his comment about, why is it that so many scientists, and I've had tons of conversations with scientists in national laboratories who know that there's a lot we don't know yet, and why is it they're not willing to kind of, go to new ground? Is funding all of it, or I just like to hear his thoughts.
Yeah, so I thank you for the question. I do think that it's the fact that a lot of scientists are afraid of taking risks or innovating and basically getting out of their comfort zone. And one thing we learned from the history of physics is very often important discoveries take you out of your comfort zone. For example, quantum mechanics, one of the main pillars of physics, took a lot of physicists out of their comfort zone, including Albert Einstein. He argued that quantum mechanics cannot have spooky action at a distance, and he was wrong. So even 100 years later, after the discovery of quantum mechanics, it still makes a lot of physicists uncomfortable, but who cares? That's what reality is. And we should be guided by evidence, not by the prejudice that physicists have to be in their comfort zone. That's the moral of this story. And unfortunately, not many physicists are courageous enough to accept that the evidence should be the key. They prefer to believe in, to stay in their comfort zone. And, it's not very different than what happened during the days of Galileo, where everyone thought that the sun moves around the earth. That was the more comfortable position. Obviously, it was flattering your ego to believe that we are in the center of the universe. And it also was consistent with some religious beliefs. And so everyone agreed to that, and that was it. But the point is, science is not a matter of consensus. It's not a majority view. It's not like politics. It should be based on evidence. And a single individual may make the correct argument based on the evidence. It's not a matter of popularity contest. It doesn't depend on the number of likes on Twitter. It just depends on the evidence. And that's what, unfortunately, many people, including scientists, are failing to accept. And the issue of funding is a byproduct. When the scientific community has a mainstream that is reluctant to innovate, then the committees that provide the funding are reluctant to innovate. And what I find strange is that in the commercial sector, in companies like Google, SpaceX, and others, and Apple, you find much more risk-taking than in academia. And that is really paradoxical, because these entities, these companies are for profit, and academia is not for profit. So in principle, and also academia has tenure, which is supposed to give professors the freedom of mind so that they will not be worried about their job prospects. And nevertheless, somehow the current culture is much more conservative and less daring, less risk-taking. A lot of scientists are worried about putting skin in the game and making, getting into subjects that may risk their reputation. And and that is really unfortunate, because we will not discover new things if we don't dare to find them. And I see that mostly the thing that bothers me the most is that in the culture of theoretical physics right now, there are lots of speculative ideas like extra dimension string theory, the multiverse, supersymmetry, and those ideas are not supported by experimental evidence, and nevertheless they have a very elevated status. They are popular in the mainstream. And how do you understand that, given that there is no evidence? It's because there is no experimental check, and therefore the people that work on these subjects do not put any skin in the game. They cannot be proven wrong, and that's a very comfortable place to be. You just demonstrate that you are smart by making mathematical gymnastics, and you can never be proven wrong because there are no experiments to test your ideas. And that's a more comfortable place to be than testing your ideas against evidence.
So how do we move traditional science off of that, paradigm where they have comfort and no one has to sit out? Because honestly, it seeps into ufology too. So you have, really great people. I was involved with the scientific pollution for ufology, but it's the same paradigm where you face a situation where the tools might not be right, but we're not thinking enough outside the box.
Yeah. So I think that the way to change the culture is to reward people that are willing to take risks. So right now, the reward system is geared towards, it's being done by selection committees that are made of the same people that do not innovate, you see. And if you were to change the reward system where you reward people that are willing to take risks, even if they fail, at least they went in some original direction that is illustrates out of the box thinking. If you reward such people, then more will follow, because it will be recognized that that's a benefit, that it enhances our chance of discovery. And so that has to change. I think the reward system, that the grants, the funding that we give should be geared towards innovation more than towards repeating things that we already know. And the other thing is, I'm hoping, I wrote my book for the younger generation, because, you wouldn't expect Marie Antoinette to embrace the principles of the French Revolution because she benefited from the old system. And so the people that are thriving in the current intellectual culture of academia will never change it because they benefit from it. They created a system that they enjoy. They have these comfort zones and they enjoy them. If you were to move them away from those comfort zones, they would get upset. And they do get upset. So my hope is the younger generation will not come in with those prejudices and perhaps will be more open-minded. And I wrote my book for the younger generation.
Excellent.
All right, well, thank you, Dr. Loeb, and thank you, Martin.
Thanks, Kevin. Great questions. All right, now we have, and I'll get back to you, Mark, after this. I know you have more questions. Greg from North Carolina, welcome to the show.
Thank you, Martin. Hi, Avi. Hi, Mark. How are you?
How you doing? You got a question for our guest?
Sure. You mentioned that we're getting better at tracking things that come into our solar system, and this is way out there, but I was just wondering, what would it take to capture one of these objects, and would it even be wise to do that and pull it into an Earth orbit or a orbit around the sun to study it further?
Right. So it's not a trivial matter to bring such an object to Earth, but what we can do are two things. One is potentially we can land on it and study it from up close, but we can also look for interstellar meteors. These are objects that collide with the Earth. So most of the meteors that we see are coming from the solar system. And we can tell that because we see the motion that they exhibit before they enter the atmosphere, before they start to burn up as meteors. And there would be a small minority of all meteors that will have initial velocity that is such that it would indicate they come from interstellar space. And I call them interstellar meteors. And if we find those interstellar meteors, which we can, then if they're big enough, bigger than the size of a person, then they will not burn up altogether. There would be something left from them when they reach the ground, and then we can examine that. So instead of capturing an interstellar object, what we can look for are interstellar meteors that we can examine when they hit the ground. And in addition, the moon and potentially even Mars, but let's focus on the moon because it's nearby. The moon collected all the objects that impacted on it over the past few billion years, because it has no geological activity. On Earth, everything that is on the surface right now, will get mixed by geological activity within 100 million years from now. And but on the moon, there is not such mixing, and everything that landed on the surface of the moon is within a few meters from the surface layer right now. And so the moon collected everything, and also it doesn't have an atmosphere, so nothing burned up. And so one way to think of the moon is like a museum. It's when we establish a sustainable base on the moon, we should go around and search on the surface for any equipment that may have been collected as a result of it impacting the moon. So I think we have opportunities either by interstellar meteors or searching the moon surface to find pieces of equipment that hit the moon or the Earth over the past few billion years.
Great. Very good. Well, I appreciate you answering that question.
Thanks for the call.
Thank you, Martin.
All right. Next, we have Louis, Los Angeles. Louis, welcome to the show.
Hey, Martin. Thank you for having me on, as always. What a killer guest. I absolutely love this show. Avi, I think I have seen every single interview you've done. Again, you're doing an excellent one. My favorite publication that you've done yet is the interview you did with the Scientific American, I believe it was.
Yes.
And the journalist that was coming at you with these questions was really pompous and very aggressive. And at first it turned me off, but what set me at ease was your confidence and your rebuttals to these really hard questions. Mm-hmm. And you almost made him look foolish by the end of the interview. And it was a text interview. You could only read this interview. And I was just, I stood up and applauded by myself in my bedroom when I was done reading it, because I'm like, we need more Avi Loebs in this world. And so my question to you, sir, is how do we get your colleagues and your peers to get their heads out of their collective butts and start looking at this data with a more open mind, with a childlike eyes? What do we need to do to get these guys on board and stop being so stubborn and closed-minded about this? Thank you for taking the question. Thank you so much for doing all of these interviews and putting all of this wonderful information out there. You truly are making some wonderful headway in this topic.
Well, thank you very much for the kind words. I mean, these interviews, there were about 300 of them over the past 8 weeks, and most of my days started at 4 a.m. in order to accommodate those back-to-back interviews. And I should say that the general public's view was pretty much, our heart was right on target, and I resonated with the general public a lot. And just like you pointed out, there are lots of people out there that agree with what I say, and that explains the popularity of the book. It became bestseller within the first week of publication on the New York Times list, and also in Germany and other places. So it's clear that the public agrees with these arguments, but it's also clear that something is wrong in the scientific culture, because I get a lot of pushback and I get attacked personally on issues, that are really puzzling for me, because I'm trying to advocate more funding for the search for technological signatures, and then some people blame me for actually arguing against that. It really goes completely opposite to my message. And I find it really strange, frankly, that somehow my scientific colleagues are not getting it. And I think that it implies that it will not be easy to change the current culture. And unless, of course, young people that enter the halls of academia in the coming years, will bring a fresh perspective into it. And I heard from a lot of people, they wrote emails to me that indicate that they are supportive of my views, people in academia, but they're afraid to speak out because they're worried about their job prospects. And that includes even senior people, that are afraid to do that. I don't care less because I think that it's important. This question is so important for the public that scientists must address it. And it's such a big issue that, I don't care how much damage I encounter, because when I was at age 18, I was recruited to the military in Israel. And there was a saying among the soldiers when I went through paratrooper training that sometimes the soldier has to put his body on the barbed wire so that others can pass through. And that's pretty much my attitude in this context, that I'm willing to suffer the pain so that the younger generation of today will be able to discuss this subject freely, because I think it's extremely important. It's one of those scientific questions that will have a huge impact on our society if we find the answer, and we have the ability to find the answer. It's only that many of my colleagues are refusing to discuss it openly. And I do think that it's just a matter of social norms within the culture, because there is no merit to the argument scientifically that we are unique and special. I mean, we should be open-minded to the possibility that there might be others on our cosmic street, and we just need to search for them. My daughters, when they were infants, they tended to think that they are the smartest. And when we took them to the kindergarten, they realized that there are smarter kids around. And of course, they would have preferred to stay at home and maintain the illusion. But, science is about getting information. And for example, you may argue, okay, we don't want that information. And look at what happened to the dinosaurs. They enjoyed eating grass and just focusing on their immediate environment, and they had huge bodies, so they thought that they are resilient to any danger. And then came this rock 66 million years ago, and 3/4 of all life forms on Earth went extinct, including the dinosaurs. So just focusing on your immediate needs and environment and ignoring the big picture is not a good approach. And we know that already from the pandemic. If you think that you can just worry about your local politics and not worry about what happens in Wuhan, China, then you're wrong, because one day the virus will come to your doorstep, and you need to understand the bigger picture in order to figure out how to respond to it. And by the big picture, I mean also our environment with the stars. We want to know who our neighbors are, because at some point, we've been broadcasting radio signals for a century, more than a century now. And if they have any radio telescopes like we possess, they may know about us already. So, sometime in the future, we might hear back. And we want to know who is around. When you enter a room full of strangers, the smart thing to do is first be quiet and listen, because you never know if there are predators around that could risk your existence. And it's really important for us to figure out who is around, because it gives us a better perspective about our place. But coming back to my colleagues, I'm really frustrated by this, and I'm worried that it will not be easy. And my hope is really that the younger generation and maybe the public will change somehow the culture. The public has influence because the public funds science, and the public should have a voice about what scientists do. And if scientists prefer to work on extra dimensions that have no, or on some forms of dark matter that have no direct impact on our lives, while ignoring the question of are we alone, the public should have a voice that's saying, no, you should actually address some of the questions that we care about.
Yeah. Are we alone? And if whoever changes that, whoever has the evidence, would be, I would think, the greatest discovery of all time.
Agree.
I don't know what else would top it. Life after death, if evidence or something like that. I don't know. Right now we have Mike from Cincinnati. Mike, welcome to the show.
Well, hi. Great show. I came late, so I'm not sure if this has been asked or not, but I'd like to ask, since you have both Mark and Avi there, why isn't there a camera on both sides of the moon, a TV camera broadcasting live back to the Earth? Talk about getting people interested. It doesn't seem like it would be that expensive. And also telescopes built on the moon. Would they be able to photograph better something like Oumuamua?
The moon is not far enough from the Earth to offer a very different vantage point, but people are discussing putting telescopes on the moon. The one advantage is there is no atmosphere. So, the atmosphere blurs the image that you get from sources on the sky. And also the moon at radio wavelengths doesn't have an ionosphere that blocks radio waves at low frequencies. And there are many advantages for astronomy to the moon. But of course, it's very expensive to bring stuff to the moon and build it there. And the idea of having astronomy on the moon is old, they are decades old, but maybe, I wrote even a paper just about a year ago about building a gravitational wave observatory in the moon because it doesn't have any seismic noise there, and it could be much more sensitive than the LIGO experiment on Earth. So there are many advantages to astronomy on the moon, but it's mainly the cost of bringing stuff there and building it there, which we haven't figured out yet because we don't have a sustainable base. There is a plan called Artemis by NASA to go to build a sustainable base on the moon, but it's not clear how quickly that would be realized, perhaps in a few years.
Can I add to that?
Yeah, sure. Go ahead.
As far as having telescopes on the moon, it's actually far better to just have them in orbit or put them at a Lagrange point, which is like a parking spot in space. If you put them on the moon, you've got other issues to worry about. That is, every impact to the moon, it still gets hit, by the way, a lot regularly, actually.
Doesn't have an atmosphere to burn up. Yeah.
Correct. And it's going to splash stuff up into the exosphere, the area around the moon. And guess what? That's going to land eventually on your telescope. So how are you going to clean it? Now you got to have somebody there. Now you have to have a way to do that.
Windshield wiper. Yeah.
Yeah, really, exactly. Which is one of my thoughts about why did Spirit and Opportunity die? Well, because there was dust accumulation on the panels for the most part, right? I mean, that started to reduce in microvolts by microvolts. They're gone. So a windshield wiper would have been great there. Perseverance has such a thing. It has a dust off built in to do that for not solar panels, but for instrumentation. But beside the point, I just think that the telescope concept is far better served by putting it up in an orbit, even if it's a very large orbit above the Earth, okay, or put it out 1 million miles away at a Lagrange point. It might be a far better solution. And that's where James Webb is going, for instance. So I think that's a better idea.
Camera thing.
What's that?
So that people could actually watch impacts on the moon and have a windshield wiper.
No, that is an interesting suggestion, and we actually wrote a paper about it with my student. I can share it with you if you send me an email, where we talked about a camera that will record impacts on the moon. Yes, that's
right. Would it be able to see meteorites going by in the atmosphere?
Yeah, that's
could watch it live.
Exactly what we were talking about impacts on the moon, but in principle you can also look at Earth. Yes,
right.
We actually we were running Avi, I run 2 observatories. I have one in Connecticut, and we're actually doing a remote view of the moon. We're actually watching the moon during a lunar eclipse, and during the height of the eclipse, we caught a meteor strike the moon.
Oh,
we're one of 5 groups on the planet that actually saw the meteor strike the moon.
I didn't know that.
Yeah. I can send you the exact location so you can actually see it. It's a little flash.
I'd be interested, actually.
Yeah, it was a very small object, but still, right? I mean, that's very good. And there's a Spanish group, by the way, that's always monitoring the moon.
By the way, speaking about the dust that you were talking about before, it's very sharp on the moon. It's different from the dust we have here because there is no atmosphere, and it can cut your. If you were to touch it, it would cut your skin.
Yeah.
Wow.
It went through the astronauts' insulation on their boots, and I forget which one it was. One of the Apollo astronauts couldn't go out for his final EVA because his ankle seal was actually cut right down to the insulation. It's because he shuffled his feet. See, you got to walk right, man.
I talked to Alan Bean, who was the fourth man on the moon. He actually put dust from a flag or something in his paintings. And I'm actually going to play this on YouTube on his would have been his 80th birthday.
Oh, I have one of his paintings. I had dinner with Alan a long time ago, actually.
Wow, his paintings are amazing.
Great guy. Yeah.
So I had something really weird happen too, but you probably have had this happen, Mark, because you're in the telescope all the time. But I happened to be at the University of New Hampshire in their observatory and looking up at Orion, and all of a sudden there was a flash across, really bright flash, and it was a meteor that went right in front of the telescope. What are the odds of that? I mean, does that happen?
Yeah, it does. We've seen them.
It does.
Here's the other thing too. Did you ever look up in the sky, and it's to you, Avi, too? Ever look up in the sky and just see a flash that's just appears and it's gone? Well, so you better duck, because that could be a meteor coming right at you, right? Yeah. No trail because it's coming right at you.
Of course, one thing to keep in mind is small objects are much more common than big objects, and the small ones, smaller than the size of a person, they simply burn up altogether.
Yeah,
right.
But it's more fun to warn people about having to duck when they see something coming right at them.
Yeah. Avi, you must have. I mean, I emailed you, and I'm not even going to say how I got your email, but you must get thousands of emails.
Oh yeah,
since this book came out,
right?
And how do you? I'm so glad you responded to me, but how do you keep up with all the publicity you just mentioned earlier? You had 300 interviews.
Yeah, well, I wake up at 4 a.m. I mean, I take some time to jog every morning at 5 a.m. in the company of birds, ducks, and rabbits. I like nature, and nobody's around at 5 a.m. And I see the sunrise, which is beautiful. But after that, starting around 8 a.m. Over the past 8 weeks, I had back-to-back interviews until 7 p.m. every day. And it's exhausting, and I try to, some days I couldn't have lunch. And I try to also answer all the emails that I get. And it's a lot of work, but I think it's important, especially because this issue is extremely important. And, my publicist in the UK, so I have a team of people that, a literary agent, editor, and publicists. And the publicist in the UK was telling me, "Great job, Avi. The book is doing great in terms of sales and so forth." And I said, "Look, I'm not marketing the book. I'm just trying to convey a message. And if the public was not resonating with my message, I wouldn't care less. I would still deliver the same message. So, the book sales could have gone down, and I wouldn't care about it. So it's just a byproduct of the fact that the public appreciates the message, and that's the way I see it. And the opportunity of having the interviews it's a platform for me to express these views, and I don't, that's the way I see it. It's difficult work because I get also the backlash from the scientific community at the same time. So some of it is quite painful, and I have to deal with all of that at the same time. So I'm trying to be resilient. Trying to behave as if I'm made of titanium.
Well, we are out of time, but I want to thank you so much. It's been such a pleasure. Really, this has been really wonderful. Thank you.
Talk to you, Avi.
And I hope you keep getting the message out there.
Thank you.
Take care. And Mark, thanks a lot. And we got to run.
All right, man. It was a great run, wasn't it?
Yeah. All right. Talk to you later. All right, everyone. We'll see you next week. And remember to keep your eyes to the sky.